It is the universal frustration of modern life. Sitting in gridlock, staring at thousands of red brake lights, thinking, if they just added one more lane, this would all be fixed. For decades, the global civil engineering response to congestion was simple arithmetic. If capacity is exceeded, increase the supply of asphalt. In 2008, the state of Texas spent $2.8 billion to expand Houston's Katy Freeway to a staggering 26 lanes, making it the widest highway in the world. Welcome to the Cobra Paradox. Today we're looking at the ultimate failure of spatial economics, how the 26-lane Katy Freeway, and superhighways just like it, didn't eliminate congestion. In many cases, they made it worse. The core mistake stems from a flawed mental model. Early traffic models often borrowed analogies from fluid dynamics. If the water is backing up, you just need a wider pipe. The paradox isn't that engineers made a mistake. It's that traffic isn't a purely engineering problem. It's human economics. Commuters don't pay for the highway with money, they pay with time. When you add a lane, you temporarily reduce the time cost of driving. In transportation economics, this triggers a phenomenon known as induced demand. Lower travel times tend to attract additional trips that were previously suppressed. People who were taking the train, carpooling, or avoiding peak hours suddenly decide to drive. Within months, the new lane fills up with trips that otherwise would never have happened. But the secondary effect is much more destructive. When you build a massive superhighway, you send a clear market signal to real estate developers. You make it economically viable to build housing developments 30 miles further out. The new infrastructure fundamentally alters the geometry of the city. The infrastructure reshapes behavior over time, increasing reliance on automobiles. By pushing populations further from urban centers, we drastically increase the VMT, vehicle miles traveled. Multiple post-expansion studies found that commute times increased within a few years. The highway wasn't moving traffic faster, it was just trapping a larger volume of vehicles in the exact same bottleneck. We tried to build our way out of a geometry problem, and instead engineered an environment where alternative modes become significantly less viable at low densities. You cannot outbuild induced demand. Modern urban planning has been forced into a radical paradigm shift. The objective is no longer to move the maximum number of cars. It is to move the maximum number of humans. Cities are executing strategic reversals. In some cases, civil engineers are realizing that the most efficient way to improve a city's traffic flow is to intentionally demolish the highway. By utilizing congestion pricing, road diets, and high-density multimodal transit, urban centers are actively reducing the supply of asphalt to rebalance transportation incentives. Whether it's fire, water, or concrete, the pattern repeats. The traffic paradox teaches us a brutal lesson. When we try to solve a complex human system using simple arithmetic, we often engineer our own paralysis. And our blind faith in simple solutions extends to the very materials we build with. Next time, we're looking at materials engineering. How a miracle mineral that was supposed to completely fireproof our cities ended up silently poisoning millions of Americans inside their own homes. Every week, engineering analysis, pattern recognition, uncomfortable truths. Subscribe if you want to understand the systems shaping the modern world. This is the Cobra Paradox.